Graphs of equations in two variables. Whenever we have to graph, I think it would be useful to actually find out what family the function belongs to. But this is something that we're gonna get very good at towards the end of the section. However, whenever I have an equation that is always showing some kind of relationship between the x-coordinate and the y-coordinate of any points that I want to plot. So even if I have no idea about the function that I'm going to graph, I can always plot points. I can always suggest values for x, and in that way I will figure out what the y's are for those x's that I'm suggesting. So in here, and this is just about vocabulary, whenever I refer to the graph, it doesn't mean the x and the y coordinates. When I say the graph, it means actually the collection of all points that belong to a particular function. So in here, the graph of f would be just this curve. So this is what is called the graph. And in the future, if I have a line intercepting the graph, I'm talking about this point in particular. Okay, so this is a line intercepting the graph. So the graph is not the xy coordinate plane. The graph is actually the actual curve. So it says the graph of an equation in x and y is the set of all the points in the coordinate plane that satisfy the equation. For example, if I'm graphing the function y equals 3, this doesn't say that the graph is simply this point, because this point is the point 0, 3. This is the graph of all the points x, y, for which y is 3. So not only the 0, 3, the 1, 3 is also there, the 2, 3 is also there, the 0.5 is also there, 0.53, the negative square root of 2, 3 is there. All those points belong to the graph of this equation. That's why the graph of y equals 3 is a line rather than just having one single dot. So that's what this equation is saying. All the y coordinates for all the points that I want to graph have a value of 3. So you just have to pay attention to what actually it says. So when I have an equation like this, like y equals x squared plus 1, all I'm saying is you can get the y coordinate of the points I'm graphing by having the x coordinate square and added 1. So for example, if I know the x coordinate is 2, what would be the y coordinate for that particular point? Well, again, the y coordinate can be obtained by squaring the x coordinate and adding 1. So that means squaring 2 plus adding 1, that gives me 5. So the y coordinate for that particular x is 5. And then I can obtain other points. Sorry, this was meant to be a parenthesis. If you know the x, you can find the y. And also if you know the y, you can find the x, but that will be something that you probably don't want to do, because that will suggest that you have to actually solve this equation. For example, if you know the y is, I don't know, let's say 10, how much would that x be? Well, if you know the y is 10, so I have to write my equation. The y is 10, x squared plus 1. This is something that tells me, oh, okay, minus 1 both sides, and I have 9. And then square root. But remember, when I take the square root, I have to put plus minus because I get two answers. So in here, x would be positive or negative, and the square root of 9 is 3. So when the y is 10, the x can be 3, and what would be another point that you can construct? With that y, you can also have this point, and both points belong to the graph of this equation. So that's how we can construct different points. You can construct different points and you will see where the function is going through. The tricky part here about just plotting points for whatever function you have is to figure out what are convenient x's to pick. Because as I'm going to show you in example 4, we will not always guess the correct x to graph. And well, not so much the correct x, but convenient x to watch, to graph. So here in example 4, I have a function. Now, if you have the exponent of x is 1, the exponent of y is 1, and there is no division involved and no multiplication of x and y involved, I am pretty sure this is going to be a linear function whose graph is going to be a line. So if I don't get a line, then that raises a flag. Since I'm going to sketch the graph, I don't need to find out what is the slope. I don't need to find out what is the y-intercept. I can just use plotting points to figure out where this is going. So I can have an x and a y. X's, you can pick whatever you want. I'm going to say with a small number since I only want to sketch. And pick also some negatives because that gives you a better idea of what the function looks like. In this line, it really doesn't matter, but in other functions, pick some negatives too. So my standard is -2, -1, 0, 1, and 2. And those always kind of work to give me a good picture. And in case it doesn't, then I have to use some other strategy. And then I'm just going to replace that in here. So it's 2 times -2 minus y equals 3. And then the question is, how much is y? So 2 times -2 is -4 minus y equals 3. I'm adding 4 both sides. So I have -y equals 7. Negative y just means the opposite. So the opposite of y is 7. So how much is y? -7. Now, if you don't get it this way, you can also think of it as -1y and divide both sides by -1, and you will get the same answer. So if one doesn't work, then the other one does work. Let me just zoom this in here. Okay, so you see how long it took us for us to find out what is the y when x is -2. And if I'm gonna continue doing that for all these other 4 values, then I'm gonna just take forever to do a problem. So what I would suggest, if you are given x values, solve this equation for y so that it's just easy to plug in and find out how much y is. So how do I solve for y? The fastest thing for me to do is add y both sides, and then I want to get rid of this 3 and subtract 3 both sides. So I have y equals 2x minus 3. So now it's a lot simpler for me to replace values of x and find out how much y is, rather than solving an equation over and over and over and over and over again. So once I solve for y, then when I replace x, that's a lot easier. So now I have 2 times the value of x, which is -1 minus 3, and that will be 2 times 4, -1, -2 minus 3, -5. And then for 0, it will be 2 times 0 minus 3, and that's -3. Then 2 times 1, that's 2 minus 3, -1. And 2 times 2 minus 3, that will be +1. So now the only thing I have to do is a sketch. -2, -7 over here. -1, -5 over here. 0, -3 over here. 1, -1. I went too fast. It's a lot easier when you have graph paper. So let's say that this is -3, let's say that this is -1 and 1. And then this one and that one. Okay. So my line is going through there, and these are the points that I graphed: -2, -7, -1, -5, 0, -3, 1, -1, and 2, 1. So those are the points. Now, if I were asked how much the slope is of this line, I can look at my equation and I can say the slope is 2, the y-intercept is -3, or I can figure out from the graph. I can say every time you go over 1, you go up 2. So the slope is 2 over 1, which is 2. And I can answer some other questions about the graph, but that will come later. Now in here, you know that this is a quadratic function, and you know that the graph of a quadratic function is actually a parabola. So you know the graph is going to look like this. But what if you always stay with positive values? Then you're not going to be able to see this parabola. You're going to be able to see only a piece of it. So let's say that I stick with positive 0, 1, and 2. So when I replace 0 in here, I have 0 squared minus 2, which is negative 2. When I replace 1, it will be 1 squared minus 2 equals negative 1. And then when I replace 2, it will be 2 squared minus 2. That's 4 minus 2 is 2. So if I sketch this 0, negative 2, 1, negative 1, and then 2, 2, I'm only seeing a portion of this parabola and I don't see the other side. So that's why you always have to be careful about the x's that you pick. I may want to add, after I sketch this, I may want to add some x's to the left of 0 so that I'm able to produce a sketch that makes sense. You are expecting this, and if you don't see that, then you have to produce it somehow by picking other x's. We're going to find a faster way to graph this, but this is just to show you that showing a table of values is the most basic tool that we have to graph a function, even when we don't have an idea of what the graph looks like. So with negative 1 squared minus 2, I cannot insist on this enough. Whenever you have a negative square, please put parentheses on the calculator if you're doing it by calculator. So this would be 1 minus 2, negative 1. And then negative 2 squared minus 2 will still be positive 2. So I have these points right here, and then I can produce a successful sketch. Now for absolute value, I know what you're thinking. I know that the graph of this is going to be a V. So again, if you don't obtain a V, then you have to make sure you pick the right x's for that. So negative 2, negative 1, 0, 1, and 2. The y's can be obtained by finding the absolute value of the x's. Absolute value of negative 2 is 2. Absolute value of negative 1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So I just graph those. Negative 2, 2. Negative 2, 2 will be there. Negative 1, 1 will be over here. 0, 0. 1, 1 will be here, and 2, 2 will be there. So I know the graph looks like this. I need to connect it with a solid line because I'm saying that not only these are the only x's that I'm plotting, but actually I'm plotting for everything in between. So if I connect it with a line, that's indirectly what I'm saying. Absolute value of 0.5 would be 0.5, and that will be the point right here. And the same happens for any numbers, for any x's that are real numbers. By me making the line solid, what I'm saying is that the function exists for all those x's in between, not only the ones on the table. The table is a guide. I know where the graph is going, but these are not the only points that I have on this function.